All right, so let's take a look at some examples for concavity and increasing and decreasing. So we're supposed to look at the functions to the right and fill in the tables that go along with them. So this first one, letter A, is supposed to be a graph of distance driven as a function of time for a California driver. All right, so um, if we're gonna have to kind of switch back and forth here with the graph in the table. That first thing we're supposed to fill in is the distance at time 0, and that is 0 right there. So I'll put a 0. Okay, at time 2, it's right there. That's a distance of 50. At time 3, we have a distance of 100. And time 5, the distance is 300. Okay, so then we're supposed to do delta D divided by delta T. All right, so the change in D from here to here is 50, goes up by 50, and the change in T from here to here is over 2. So that's going to work out to be 25. Okay, this one between these two is 50 over 1, so that's 50. And then these two, the difference is 200 divided by 2, and so that's going to be 100. So these would be our rates of change. And what do you notice about the rates of change? Are they increasing or are they decreasing? They're increasing. So since these rates of change are increasing over time, this would tell us, if we didn't have a graph, this would tell us that this graph is concave up. We can kind of see it in the graph already, but if we didn't have a graph, that's how we would determine whether it's increasing or decreasing. So let's look at the next one. At time 0, it's 0. Okay, this is a graph of distance driven as a function of time for a South Dakota driver. So it starts at 0. At time 2, he's at 150. At time 3, we'll call that 175. And at time 5, is at 200. Okay, so again, we have a difference of 150 divided by 2, a difference of 25 divided by 1, and a difference of 25 divided by 2. So this is going to be 75, 25, and 12.5. Are those values increasing or decreasing? Our rate of change. Okay, from here to here, it's decreasing. So since it's decreasing, this would be concave down. Okay, now, what do those two things mean in terms of our travel? Well, the California driver, if it's concave up, its rate of change is increasing. That means it's going faster over time, all right, which is why it's increasing more towards the end than in the beginning. Whereas the South Dakota driver is slowing down over time. It's concave down. All right, let's take a look at this next one. This next one is supposed to represent the amount of a decaying Twinkie as a function of time. All right, so at time 0, the value of A is 4. Let's see, we're doing 0, 4, 6, and 10. So here was 0. At time 4, we're at about 2. At time 6 and time 10 are other 2. Okay, so for 4, it's 2. For 6, it's, let's see, 1 point, we'll say like 1.35, 1.4, something like that. I'll do 1.4. Well, that was not good. 1.4. and then at 10, we're looking at about 0.75 or maybe 0.8, somewhere around there. I'm going to go 0.8 because I know it's going to be easier to calculate. Okay, so change in A divided by change in T. Change in A is -2 here, divided by 4. This one is going to be negative 0.6 over 2. And this one's going to be negative 0.6 over 4. All right, so this is going to be negative 0.5. This is going to be negative 0.3. And this one's going to be negative 0.15. All right, now, are those rates of change increasing or decreasing? It's going from negative 0.5 to less negative numbers. So technically that is increasing. And if our rate of change is increasing, then our graph should be concave up, which it is. All right, last one. Again, we kind of know this is supposed to be concave down. This is the amount of ice cream remaining in, or sorry, the amount of ice remaining in a melting ice cube. I must be hungry. Ice cream sounds really good right now. Okay, so at the beginning, we have a value of 4. All right, and then when time is 4, it's at a value of about 3.5. At 6, it's a value of about 3. And at 10, wow, we're all the way down to 0.5. These are a difference of negative 0.5 divided by 4. This is a difference of negative 0.5 divided by 2. And this is a difference of negative 2.5 divided by 4. Okay, so negative 0.5 divided by 4 is going to be, let's see, negative 0.125. Negative 0.5 divided by 2 is negative 0.25. And then 2.5 divided by 4, let's see, that's going to be negative 0.6. Is that 625? 115. Let's see. Sorry. 25 divided by 40. 6 is 240. 100. Yeah, 625. Let's see. Is that 0.0625? Let's see. It was 2.5 divided by 4. Oh, all right. Sorry, I got to pause here. Yeah, that's good. Okay, so this is going from a negative 0.125 to a negative 0.625. So it's getting more negative, which means it's actually decreasing, which means, and these are the rates of change are decreasing. So therefore, since the rates of change are decreasing, this is concave down. Crazy how that works. All right, got one last video. Stay tuned.